Hi everyone, welcome to our next video in the Week 1 series on histograms. So what is a histogram? A histogram is a graph that's specifically used for quantitative data. And remember that quantitative data is numeric data. So histograms are used for numeric data for a single random variable. They are similar to bar charts. They're going to look very, very close. Except that the bars in the histogram should touch, whereas the bars in a bar chart do not. Histograms typically have vertical bars, which again is different from a bar chart where we could make our graphs vertical or horizontal. In this case, the x-axis is going to be the quantitative data intervals. So histograms are for grouped data, and the y-axis will be the frequency or the relative frequency. A quick reminder, it's been a long morning. If f is frequency, the n is the total number of data values, our relative frequency, rf, is equal to f divided by n. So here's a sample of a histogram, and we can see that x and y axis labeled as was stated on the last slide. So on the x-axis we have data values, specifically those boundaries from a frequency table. So each bar represents a range of data values. And then the y-axis is labeled with, in this case, relative frequencies. So that 0.05 for the first class means that if we took the frequency for that range and divided it by the total frequency, this class makes up 5% of the data. So let's talk about how to build these from scratch. The first thing we need to do as the researcher who's building the histogram is we need to decide how many classes we want to use. Usually we work with histograms from about 5 to 15 classes. I personally prefer about 5 to 10. You get too much over 10 and the graph starts to get really cluttered and difficult to read. Another thing to consider when you're choosing the number of classes is we know we want to take our data and split it up into a nice even number of intervals. So if you know how wide your data is to start with, you might want to choose your classes so that it fits evenly into that range of data. To figure out the range of data, how wide it is on a number line, we're going to find our starting point, which is half a step below the smallest value in your list, and then the ending point, which is half a step above the largest value in your list. Then we're going to find the class width, which is the width of those bars in the histogram, and is also the width of our classes in our frequency table. So to figure that out, we take the ending number minus the starting number, and we divide it by the number of classes or bars we want in our histogram. We're then going to use the class width to make a frequency table. In step 4, if you ended up with a number that's not a nice, pretty whole number, you can always round it up to the next nearest whole number. You don't want to round it down because then you might run out of space in your frequency table and you'll have data that doesn't get represented in your table and your histogram. So if you end up with a decimal at step 4, always round it up if you want to count by whole numbers. Once we've decided on that class width, we're going to use it to make our frequency table. So you start at that smallest value, that half step below, and then you add the class width to get the upper boundary, and then you keep adding that class width to create your table. We're going to do an example in a second so you can see what that process looks like. But steps 1 through 5 are all about constructing that frequency table. That's where most of the math is. Once that frequency table is built, all we're doing is summarizing that in what amounts to a numeric bar chart. We draw and label our axes. X-axis should be those class boundaries, the first column of your frequency table. And the y-axis should be frequency, which is the second column, or relative frequency, the third column if it's present. Once your axes are labeled, just like a bar chart, you're going to draw a bar to represent each class frequency. So the height of the bar should correspond to the frequency or relative frequency for each row of your table. So let's go ahead and look at how that process plays out for an actual data set. So for our example, it says create a histogram for the following data. The number of books bought by 50 part-time college students at ABC College. The number of books is discrete since books are counted. And they did a really nice thing here. They sorted this data and listed it so that like numbers are grouped. So I've got a whole list of 1s, list of 2, list of 3, list of 4, and list 5 and 6. So let's use that data to go through that step list we saw on our previous slide. So our first step, we want to go a half a step below the smallest value in our table, our minimum, and we want to go half a step above the biggest value in our table, our maximum. So our starting point is going to be 1/2 step below the smallest. So 1 minus 0.5 is 0.5. And same for our ending point, except now we're adding. We want a bigger number. So our ending point should be 6 plus 0.05. The reason why we're doing this, we're adding and subtracting 0.5, we're shifting our start and end point, is we're trying to prevent our actual data values from falling on the edge of the boxes. That makes it harder to interpret. Let's go back really quick to our sample histogram. In this picture, this first bar actually represents data values between most likely 60 and 61.9. They went half a step below 60.0 and half a step above 61.9 so that those data values aren't on the edge of a box. We don't want boundary values, or data values rather, on the edge of a box because then we can't tell, does it belong in the box behind 61.9 or does it belong to the box in front of 61.9? Where did it get counted? So this long step list that we see on this slide is all about preventing data points from falling on the edge of one of those bars in our frequency table and our histogram. So back to where we were, we've decided our start point and our end point. Next step, we need to figure out our class width. And to do that, we need to know the number of classes we want to use. Our width for our data is end minus start. So 6. And I know that 6 divides into 6 evenly. So if I use 6 classes, I'm going to end up with a nice pretty class width of 1. I like that because it's an easy number to count with. We, remember, have control over that number of classes value. Sometimes you're going to encounter problems in the book where they'll tell you which class to use, but if they don't give you this number, you get to choose this number. And if you make it a number that either divides evenly into that data width or has some common factors, you're going to end up with a class width that's a little bit prettier and probably easier to work with. Okay, our next step is to use that class width and our starting point to build a frequency table. So here's a blank frequency table. You can see that I've put 6 rows in that frequency table for our 6 classes. And then a reminder that our starting point was half a step below 1, and we decided our class width was 1. So our first class is 0.5 to 1.5, starting point plus 1. The next class is going to start with 1.5, and then 1.5 plus 1 is 2.5. And this pattern will continue. I'm going to bring that upper bound down to the next row for our lower boundary, and then add 1. Bring the upper bound down and add 1. We should check at this point that that last row is big enough to contain our biggest data point. So does 6 fit in this table? And the answer is yes. 6 fits exactly halfway between 5.5 and 6.5. So we've probably constructed this table correctly. And then filling in the frequency column is just a matter of counting data points. So we count the number of 1s, and I counted 11. You should double check me. Count the number of 2s, and I get 10. For 3s, I got 16. For 4s, I got 6. 5, I got 5. And 6, we can see we have 2. So that is the bulk of the histogram math. Building a histogram needs a frequency table. If it's given to you, this isn't so bad. If it's not, you need to go through those first 5 steps and build this yourself. So let's go ahead and take our frequency table and turn it into a histogram. So that first step was to draw your axes. And remember that your x-axis should be the class boundaries. So I can see in my table my smallest boundary is 0.5, my biggest is 6.5, and I'm counting by 1. And you see that along my axis. You'll also notice that the axis label is actually the quantity that we were counting with these classes. That list of raw data on the previous slide was a count of the number of books. And so that's what I wrote down here. In this case, we have frequency and not relative frequency, so my y is labeled frequency. And looking at that frequency column, I can see my biggest frequency is 16. So I made my y-axis long enough that 16 fits on the graph. Once we've done all that labeling, now we just go through and make our bars. So my first bar should be up to 11 on the y-axis, which is going to be right up here. Our next one is going to be 10, which should be right here. Third row is all the way up at 16. Next one is way down to 6. Next one is at 5. And our last one is way down here at 2. So a couple of things to notice. First, the bars touch, which is what we should see. The only time you're going to see a gap between bars is if one of the rows in your table has a frequency of 0. Otherwise, the bars should touch. Next thing you'll notice, I did color them in. It's not mandatory, but we do kind of want to make our charts aesthetically pleasing because we're usually trying to convey information to others and we want to grab their attention. It is important to make sure that your graph isn't so distracting that people miss the shape of the graph because of your color choices. So neon colors are probably not a good choice here. Different colors for different bars are also generally not a good choice unless those bars are coming from different data sets, and that's something we're not going to deal with in this class. So we generally want a uniform color and a nice, simple, but very clear and well-labeled graph. So what I'd like you to do is I'd like you to pause this video, take a second, and create that frequency table for this set of data. That's probably the hardest part of creating a histogram, and I want to make sure that you know how to do that. So pause this video, and then I'm going to keep going and show you what that solution is when you come back. Okay, so for this problem, it says the data below represent the daily high temperatures in a California town for 1 month. Create a histogram for this data using 6 classes. So this problem specifically told us when we divide our range, we're going to divide it by 6. I want 6 groups for my frequency table. So this looks exactly like it did before. Our smallest is 61. Our biggest is 95. Half a step below the min is 60.5. Half a step above the max is 95.5. And the distance between those two numbers is 35. The next step, we want to take that distance between our max and our min, our smallest and largest. We're going to divide it by the number of classes, which is 6. And in this case, we don't get a nice pretty number, we get a decimal. But counting by 5.8 is difficult, so I'm going to round that up to 6. Ideally, what happens when we do this is that biggest data value will fall somewhere in our last row, but it won't be at the very end of that last row. There's going to be some wiggle room there. All right, now that we've got our class width of 6 and our starting point of 60.5, we can start building our table. So 60.5 is our starting point. To get the next boundary, we add 6. We pull it down and add 6, pull it down and add 6. And you can see that I've got 6 rows in my table for 6 classes, and that last value of 95 does fit in that last class. I've also gone through and counted, so it should be 5, 11, 11, 2, 0, and 1. And then when we graph that, we get a picture that looks like this. You'll notice it's labeled, just like my last picture was labeled, but this one wasn't hand-drawn. This one was actually done in Google Sheets. You have the option of using any number of digital tools to help you build histograms and other graphs. There is a guide on Canvas for week 1 for how to use Google Sheets to make most of the graphs we're doing. You can also do those graphs in GeoGebra, and those should be in the GeoGebra calculator guides, which are also posted on your week 1 links and videos page on Canvas. All right, if you have any questions on how to make those frequency tables or histograms, let me know. Otherwise, I'll see you in the next video.